There we go. All right, so I'm going to implement a new reward system. When a student does something great, you pick a bead out of my giant bead jar. If the bead is red, you get a piece of candy. If not, you don't. You don't win anything. The question is, what are the chances that a student chooses a red bead? Each group will get a sample of beads and we'll create a confidence interval, that's the whole point of this chapter, to estimate the true proportion of red beads. The group with the smallest interval will win the prize. Okay? So you don't know what an interval is yet, and that's okay. Right now, what you need to do is you're going to select, what I've taken is my big bead jar and divided it up among the room so we don't have to all come up and get some. Okay? You're going to take 20 beads out of the cup. If there's not enough for everybody in the cup, then just get as many samples of 20 as you can. Okay? And you're going to count how many red out of your sample of 20. Alrighty? Let me know what to do? All right, ready to go. Get
10.
You got 10 out of 20?
Yeah.
Oh, that's easy. Okay. So 10 out of 20, you're going to put your number in that blank. You got 10 out of 20, okay? This is what we call our point estimate. It's what we get from our sample. It's our starting place. Remember, the big idea with statistics is to use a sample to help us predict something about a population, right? Starts with a sample, and that's what our point estimate gives us. Now, identify the population parameter sample statistics. This is a throwback to that vocab we were doing before Christmas. What's the population we're interested in here? All the beads, right? All the beads. And what are we interested in about these beads? How many are red? But more specifically, we want to know the true proportion of red, right? Remember, proportion is another word for percent. And when we use a parameter, we use the symbol P. Proportion or percent of red beads. That's what we really care about. So what was our sample? 20 beads. And the statistic is the percent from our sample. So we use, remember, the symbol P hat? Now, in Trenton's sample, we had 10 out of 20, which is easy. It's just 50%, right? You figure out yours. Okay. Now what we're going to do is change our point estimate into an interval of values by adding and subtracting something to it. Okay? Because here's the deal. Are all our samples the same?
No.
Are we surprised by that? No. Do you think any person's sample in here is the exact right percent of the whole jar? No. We know it's not perfect, right? So we need to build in wiggle room as an estimate of the whole thing. So we're going to start with your point estimate. So I'm going to start with, so if mine is 0.5, so I'm going to start in the middle, and I'm going to add something and subtract something. It's the same value. So for instance, I don't think it's really 50% red in the jar. But I think maybe if I add 15% on both ends, maybe it could be between 35% and 65%. Think that's more plausible?
Yeah.
Somewhere between 35% and 65% red. So whatever value I added, I have to subtract. So what did I do? I subtracted 15 and I added 15. You can add and subtract whatever you want in this example. All right? So it says use your point estimate and chosen margin of error. This is my margin of error that I chose. And we're going to create the new interval. So that's kind of what I did visually here. But when we write our intervals, we'll do this in parentheses, 0.35 to 0.65. All right? We always put them from lowest to highest, parentheses with the comma between. The point estimate is the center. We don't necessarily write it down, but we can figure it out. Now then you ask yourself, well, how confident do you feel that your interval captures the real proportion of red in the big jar? Like, what would you say, 70%, 80%, 90%? Confident?
Probably
70%. 70%? Yeah? Okay, I'm going to say I'm 80% confident. Just put in what you think right there. It doesn't matter really. okay? And we'll talk more about that in the next simulation about what the confidence really means. Now, backtrack for a second. Let's say one of our groups has an interval of 0.27 to 0.33. What is their point estimate? How could we figure that out?
You could add a number to the bottom number and subtract a number from the top number and get the same answer. Something like that.
You're on the right track. You're on the right track.
Oh, it's the median.
It's just the middle, yeah. So if I visualize my interval like this, here's my point estimate, the point. And the low end of theirs is 0.27 and the high end is 0.33. What's in the middle? 0.3. You see it? So that would mean that my point estimate is 0.3. And then what is the margin of error that was used? 0.03. Sometimes it requires actual math, sometimes you can just see it, right? And I'll give you a formula for it, but this is kind of how it works. So then it says one group claims that the true proportion of beads is 0.25. That's the real proportion. Does your interval support or deny this claim? So you go back to your interval. I'm going to go back right up here, when I was right here. And I'm going to say, okay, does 0.25 fall within this range? No. So I don't have any evidence that 0.25 is the truth. What the interval does for us is give us a range of possible, plausible values for the true proportion or parameter. Okay? If my claim isn't in there, then I can't support it. If it is in there, I can support it. It's that simple. All right? So for me, I cannot support this claim because it does not fall in the interval. It might fall within yours. Does it? Okay? So here's how I would phrase my sentence. I would say, since 0.25 does not fall within my interval, or the interval, we must deny the claim of 25%. Okay? Obviously, if it fits in yours, then you would support the claim. Easy enough? Okay. By the way, the true proportion of red was 30% or 33%. Did you get 33 in your interval? Based on your sample? Yeah?
Yeah, I kind of figured that out, like when it was red, white, and blue. Yeah,
I know. It's not very cryptic, is it? All right. Let's look at the next page. What do you need to know from this? Okay, this is, again, the introductory lesson. I fully understand that. So, what do you need to know? Okay, so some vocab that will take us through the whole chapter, honestly. Point estimate is a statistic that provides a reasonable estimate about the population parameter. So, if my point estimate is a p-hat, that means that the parameter is p, right? If the point estimate, the sample is a mean from the sample, then what's the parameter I'm trying to predict? Well, just mu. Just mu. Just mu. Alrighty. Now, for interval A to B, okay, that's just some number A and then B, all right? Just to kind of be really generic in how we define these. How can we find the point estimate if I know the low and the high end of it? What did we say? Straight up find the middle, right? So, algebraically, that's just the average. So, it's A plus B divided by 2. If A is here and B is here, the point estimate is right smack in the middle. So then what would we do to find the margin of error?
Subtract the middle from A.
You could subtract A from the middle, or B, or the point estimate from B, or you can just subtract B minus A and divide by 2. Honestly, most students don't use the formulas. You just kind of see it and you can figure it out. Okay? Now we will be interpreting confidence intervals, and this is the sentence we use, okay? It says this, we are, and then it'll tell us how confident. 90% confident, so C is for confidence level. Whatever percent confident that the interval from A to B, lowest to highest, captures the true, and then I'm just going to put this in brackets, the parameter in context. Captures the true percentage of red beads. Whatever it is, okay? And then lastly, the fourth thing to take away here is confidence intervals contain different plausible values. See if I can spell it. P-L-A-U-S-I-B-L-E. Plausible values. So anything in the interval is a possibility. All right? And that helps us make or support or deny a claim based on that. All right? Now, let's look at this application problem. We'll do it real quick. Random sample of 100 adults are asked if they pay for monthly subscriptions they don't use, like a magazine, an app, an online program. Many do because they've never taken the time to cancel the subscription. A 95% confidence interval for the proportion of adults who pay for subscriptions they don't use is 0.352 to 0.584. All right, A, B, C. I want you to do an A and B. I want you to attempt C. If you can't do it, just hold on and we'll do it together. The wording is a little different than you've seen, but you probably figure it out. A, you're interpreting the interval using that sentence we have right up here, this guy right here. And B is you're going to find the point estimate and the margin of error. Okay? They gave us the interval right here, 0.352 to 0.548. All right? I'm going to give you a couple minutes, and then we'll come back and check. Alrighty? That the interval from 0.352 to 0.548 captures the true proportion of adults who pay for subscriptions they do not use. So notice the context in there. I don't have to come up with that out of nowhere. That's given to me right here in the stem of the question. So all I have to do is copy paste, right? Point estimate, show your work, margin of error, there it is. Easy peasy. Now, the claim thing, look at part C. Based on the survey, a reporter claims that a majority of adults continue to pay monthly for subscriptions they don't use. Use the confidence interval to evaluate. Okay, so let's stop and think. What does majority mean?
50%.
So more than 50%. So that would mean 51% or higher, right? So look at our interval. Is 51% in there?
Yeah.
Yeah.
Yes. Is the entire interval higher than 51%? No. So do we support or deny? Remember, the interval is all the plausible values. So the truth could be the low end of the interval. So we have to deny it. The only way we could support the claim is if the whole thing was 51% or higher. Does that make sense? So how would I state that? I would say, since there are values smaller than 51% in the interval, we have to deny the claim. Deny the claim that the majority of adults have subscriptions they don't pay for. We okay with that? All right, that's the first part of the concept of a confidence interval. It's a range of values that we think the truth falls within, because we are looking for the truth ultimately. All righty? So we're going to switch gears